All right, so this is an example of how to work with different data displays. So in this case, the results for period 5's unit test, operations with rational numbers, was given to us in a dot plot. I took the values from the dot plot and I put them into a data value list that you see down here. So basically, you can see that every dot on the dot plot is one piece of data or one student's results. And then I just took those pieces of data and I put them into this list so I can do some different things with them numerically. That might be a little easier for me. All right. So you can see 58, 58. These are 63 because they're halfway between 62 and 64. That's 63 and 63. Here you've got 75 right there, halfway between 74 and 76. Here you've got 80 between 82 and 84, so that would be 83. So that's why we have two 83s here, and so on and so forth. So you guys can kind of see for yourself how I generated that list. Once I have generated the list, the next thing I would recommend you guys do with that list is you go down to your stem and leaf, and you start filling out your stem and leaf, okay? So here it says, take the scores from the test and organize them into an ordered stem and leaf plot. Make sure to include a key. The stem and leaf plot to create, use the stem and leaf plot to create a histogram for the data. All right, so what we're going to do is we're going to take that list. I'm going to kind of zoom out a little bit so we can see it. There we go. And we're going to do the key first. Now, if you remember how to do a key for stem and leaf, you're basically just saying where the place value delineation is. So if we say, let's say 58, and we say that's going to be 5/8, where 5 is the stem and 8 is the leaf, then that's going to be worth 58. It tells us that that delineation is between the tens and the ones place. Okay? So now we can read our value list here. So I'm going to go here and take all these values and put them on our ordered stem and leaf. I think that's a good thing for you guys to do as well. So if you haven't done it, please do it as I do it. Okay? So 58, here's 58. Then you've got 63, 63, 63, 63. You got 75, 75. You got 83, 83, 83, 83. You've got 88, 88, 88, 88. There's 4 88s, so you're going to put 4 8s here. Okay, 88, 88, and so on and so forth. You've got 1, 2, 3, 4, 5, 6 92s. So on the 90 to 100 interval, you're going to do 92, 92, 92, 92, 92, and 92. You've got 3 96s, so 96, 96, 96. You've got 1, 2, 3, 4, 5 100s, so that's going to be 100, 100, 100, 100, 100. That's 5 100s. And then you've got 104. Now that would be 104, just like that. So now you've got all your data points on our stem and leaf. Now remember, we want to make sure we didn't lose any data. So I would at that point count. I know I have 25 pieces of data in all. So let's make sure we didn't miss any data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we have that very same 25 pieces of data we had to start. We didn't lose any data. That's great. Once you have done that, and the reason I recommend you do this first is because now when you're doing your mean or calculating your mean, you can do a little thing called subtotals, right? So if I do subtotal title over here and I go through, I can actually kind of calculate the subtotal for each of these intervals as a means of getting my total value for the mean. Okay, so let's see what happens there. I've got 100 times 1, 2, 3, 4, 5, so that's 500, plus 104, so that's 604. So my subtotal for this one would be 604. Here, I got to do it on a calculator because I don't want to do that all in my head. So I'm going to grab a calculator. Let's see if this pops up. Where's my calculator? Waiting for my calculator to show up. Come on, calculator. Okay, wait, there it is. Slow computer finally kicks into action. There we go, 92. So we're going to do 92 times 1, 2, 3, 4, 5, 6. So we got 92 times 6. And 92 times 6 is, in fact, equal to 552. So I'm going to start with that 552, and then I'm going to add 96 3 times. So plus 96, plus 96, plus 96. And so our total for that would be 840. So we're going to put 840 here. And then we're going to do our next one. So we've got 83, 83, 88 times 4, basically. So I'm going to do 88 times 4 to start. Then I start with 352 and I add 83 to it twice. So plus 83 plus 83. And you get 518. And then you've got 75, which is just 75. You've got 63 and 63, which is going to be 126. So that's easy enough to do in our heads. And then you got 58. So the advantage is that once I have it as subtotals, I can add it all up and get the total value for everything pretty easily. So now I can grab that same calculator that was slow to show up initially and use it to get our total value. So for all the results, all the data, this is the sum of the data. 604 plus 840 plus 518 plus 75 plus 126 plus 58. And that is equal to 2,221. So that's 2,221 as our total value. Now I can go back up here and I can say for the mean, it's pretty easy to calculate the mean now, right? It's just going to be 2,221 divided by the 25 pieces of data. So now we can take that 2,221 divided by 25, and we're going to get our mean. And our mean is, in this case, let me see if I can erase that. Our mean is 88.84. Okay, so we have 88.84 as our mean, and we can write that in here, 88.84. Now I'm going to write that in two ways. I'm going to say 88.84, and then I'm going to say approximately 88.8. Because when we're using the mean to calculate the MAD, I think rounding it to the nearest tenth makes it a little easier to calculate, and I think that's accurate enough. I recommend that you guys always use the nearest tenth when you're using your mean to calculate your MAD. So now we have our stem and leaf done. We have our total for our mean done. That was pretty nice. Now let's go back up here and take a look at our mode, which is the result that happens the most. That's what the mode is. We can see that the result that happens the most in this case is 92. There were 1, 2, 3, 4, 5, 6 results of 92. So that means that is our mode. It is the most frequent response, the most frequent piece of data. Okay. The range is the change from the highest to the lowest. So in this case, it's from 58 all the way to 104. So you just do 104, take away 58, and that's going to give you your range. So our range in our case here is just going to be 104 take away 58, and our range is 46. So you guys should have 46 as your range. Okay? The median is the middle of value. So later on, we're going to do a box plot with this data. So let's just set up our box plot values right now, one of which is the median. The median in a 25-point list here is going to be exactly halfway, so 12 on either side. And so we just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that 13th value is going to be our median. So there is our median. Because it's an odd list, if we were doing our box plot, that median is on the list, so it splits the data into low and high. So let me show you guys how the upper and lower parts of that data get set up. You have the upper part of the data, which is going to be all of this. And you have the lower part of the data, which is going to be all of this, okay? Because there's a true middle, a true median on the list, it splits the data into low and high. You've got 12 values in the low section, 12 values in the high section, okay? When we're looking at the low and high sections, remember the upper quartile for our box plot later on is going to be the median of the upper section. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Where would halfway be? It'd be 5 on either side. So 1, 2, 3, 4, 5. Then there's the 2 in the middle. And then 1, 2, 3, 4, 5. So we have our 2 in the middle that we're going to have to average to get our median of the upper part of the data, which would be, I'll call our upper quartile. Over here, 1, 2, 3, 4, 5. And we've got our 2 in the middle that we're going to average to get our lower quartile. And then remember the other point of data we need for the box plot is our extremes. 104 is one extreme and 58 is the other extreme. So you guys can see that just by doing that with our list, we have all our 5 points of data for our box plot. So when we need to do that later on, we already have it in place. Okay? So now I've got my, my median figured out. It's 92. That was easy enough. Cool. Let's take that median and write it in, 92. The only thing we have to calculate in this section that we haven't done yet is the MAD. Now you guys remember what MAD stands for? It can either stand for mean absolute deviation or mean average deviation. I like to think of it as mean absolute deviation, just to remember that the deviations, doesn't matter whether they go up or down, it's the absolute value of those deviations that you're summing together. And so basically, if you remember what MAD is, it's the average distance of each data point, okay, whether it goes up or down, irrespective of direction, from the mean, okay, from the middle. So it's a measure of spread. Now, in order to calculate that, we have to be very precise and very accurate. So let me show you the way that I would like to calculate this data, and I'll show you my process. So the first thing that I like to do is I like to list out the absolute value difference in one step. So I know that I'm going to be taking it away from the mean, which is 88.8. So, or I should be subtracting the mean from that. So what I would do for the MAD here is I'm going to start by just listing out all my deviations, all my absolute deviations. So the first thing I would have is 58, that first data point, take away 88.8. Okay, and whatever that's worth. The next thing I'm going to have is going to be 63, take away 88.8, because you want to have the deviation, right? We want the absolute value of that because we don't care whether it goes up or down. Now remember, in the 63 case, we have how many of those? 2. So I'm just going to multiply that absolute deviation by 2 because that will give me the total deviations for that value. And it means I can be a little more concise in the way I write it. Here we have 75, so that's going to be the absolute value of 75 minus 88.8. Then we have 83 that happens twice, so that's going to be the absolute value of 83. Let me write that a little neater for you guys. 83 minus 88.8, absolute value. And that happened twice, so I'm going to put a little 2 on the outside so I can multiply that by 2. Then you have 88 that happened 1, 2, 3, 4 times. So over here, I'm going to put absolute value of 88 minus the mean, which is 88.8. And that happened 4 times, so put a little 4 on the outside. So we're going to multiply that by 4. And then you have 92 that happened 6 times. So you're going to put 92 absolute value minus 88.8. And we're going to multiply that by 6 because it happened 6 times. Then we have the 96, which happened 3 times. So you do absolute value of 96 minus 88.8. And we're going to multiply that value by 3. And then you've got the 100, which is going to happen 1, 2, 3, 4, 5 times. So 5 times the absolute value of 100 minus 88.8. And then last but not least, you've got the 104. So that's going to happen once. So the absolute value of 104 minus 88.8. Now, normally I would just do all that out, but because I want to save time on the video and not make you guys bored with me punching things into a calculator, I'm going to stop there, do the calculations, show you what they are, and then resume the video. All right, so after some calculator work, you guys can see that I got all of our absolute deviations here in blue. We added them all together. We got 223 as our total absolute deviations. And then you take those and divide them by the number of deviations, which is 25, to get your MAD. So your MAD is 8.92. Okay? And what does that mean? It means that on average, each point of data is 8.92, either above or below the mean. Okay? So it's a measure of spread of the data. All right, now let's take a look at our histogram down here. So we already did our stem and leaf. That was pretty cool. So we can do our histogram just as easily. When you're doing the histogram, the only thing you have to do that's a little tricky is you want to make sure you understand how to label it. So in our particular case for this particular set of data, this is all going to be related to the operations of rational numbers test. So that would be what you title it as, ops with rational numbers test. So that's what you put as your main title for the histogram. The left-hand side, the y-axis, is going to be the number of students or number of results. So I'm just going to kind of see if I can write this sideways, number of students. Okay, and then the bottom value here is going to be the scores themselves. So the score range, right? Okay, cool. And over here we got our stem and leaf. We're just going to take that and transcribe it onto our histogram. The intervals match up pretty nicely. So first of all, between 50 and 60, you have one value. So I'm going to use these little rectangles to help us out. I'm going to zoom in a little bit because I can, and it's computer, so it makes it easier to zoom in. I know that in real life you guys can't necessarily do that, but that is one of the bonuses of having a computer. Let me see if I can get this to slide over this way. All right, cool. So when I zoom in, you guys can see that if I'm being a little more precise here, that's going to be 2, that's going to be 1, that's going to be 3, right? So I can kind of see 1, 2, 3, 4 here. So I counted by 4s so that I'd have room in any interval bin for all the students to fall into that category. But obviously, if you were creating your own histogram with your own custom y-axis, you probably want to count by something smaller than 4, right? Or something that's going to be a little more zoomed in, like 1 or something like that, right? If you could, or 2. But for our purposes, I'm going to have to use these like smaller delineations. So let's take a look over here and see what happens. So our first section is, like we said, 58. So that's between 50 and 60. So I'm going to grab a little rectangle tool here, and I'm going to do between 50 and 60. So 1. So I'm going to go up to that level of 1 that we had there. Perfect. Okay. Then for the next one, from 60 to 70, we have 2. So I'm going to go halfway on that. Then from 70 to 80, we have 1. So back down to the level of 1. And then from 80 to 90, you have 1, 2, 3, 4, 5, 6 points of data. So that's going to be 6, which is basically 1.5 of these sections. Okay. And then let me zoom out a little bit so I can do the next part. From 90 to 100, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be 4, 8, and then 1 extra. There you go, 1/4 of the way up to the next line. There's our 9. And then when we're talking about the last section here, the 100 to 110 range, you're looking at 1, 2, 3, 4, 5, 6. So there's 6 values there. So we're going to just kind of scooch this over a little bit and go up to 6, which is 1.5 again. So just like that. Okay, and so this is how you create your histogram for the data, and that's what your histogram would look like. Hopefully you guys all feel comfortable with that. Okay, now I'm going to kind of zoom out a little bit and talk about your box plot. The nice thing about the box plot is we already have the data worked out here at the top in pink. So all we have to do is now make the number line. The number line should go from 58 to 104. So I'm just going to make it easy for myself, and I'm going to start counting basically with 58. Actually, you know what? Let's give it a little room on the left-hand side. Let's count by 2s, and let's start with 50. Okay. So we have the number line here: 50, 52, 54, 56, 58, 60, 62, 64, 66. You guys might be wondering, why did I skip like I skipped? And if you're wondering why I did that, the reason is I don't want to feel crammed in writing everything, because if I try to write and label each and every line, then it's going to get really messy, right? So if I leave myself a little space, a gap, and I label every other one, it's a lot neater, and I can still read the number line just fine. Remember, when you're doing your number line, just make sure that the distance is always the same value. This distance is always 2. So I'm counting by 2s. That's my interval. So 62, 66, 68, 70, 72, 74, 76, 78, 80, 82, 84, 86, 88, 90, 92, 94, 96, 98, 100, 102, 104, 106. Okay? So now I've got my number line all created nicely. All I have to do here is label this, create a box plot for what? And this would be the ops with rational numbers test. And then I'm going to, of course, put my dots on. So if you remember your dot plot, there's the 5 points of data you need. You need the lower extreme, the upper quartile, the lower quartile, and the median. The lower extreme is 58. The upper extreme is 104. So let's put those on first. That's what this bottom thing is for. So we got 58. That's our lowest value. You've got, that's a little bit thick, huh? Let's change it to 3 or 2. So we got 58. Our maximum score was 104. That was our upper extreme. Remember what our median was? Our median was 92. So that's going to be right there. There's our median. And then the other 2 points we need is the upper quartile and the lower quartile. And the upper quartile is between 96 and 100. So that's going to be 98. So we're going to go down here and do a dot at 98 for the upper quartile. And then the lower quartile is going to be between 83 and 88. Well, that's 5 units of distance, which is 2.5 added on to 83. So we're looking at 85.5. So 85 is going to be exactly halfway between 83 and 88. So it'll be 85.5. So we go down here and we do 85.5. Here's 84. Here's 85. There's 85.5. Looks like it's right about there. Okay. Once you've done that, you're going to make your box. And your box is going to look like this. It's going to be quartile to quartile. Now I'm going to use the guidelines I have here. So quartile to quartile. And then I'm going to do a little line down the median. And I'm going to extend the whiskers out to the edges, just like that. And there's your box plot. That's it. That's how easy it is, right? So you've got your box plot. You have that now created properly. And if you wanted, you could label it, right? You could say that the lower extreme, let me write that in a little bit nicer way here. Sorry. The lower extreme is going to be 58. That the lower quartile is going to be, we said it was 85.5, I believe. So it's 85.5. And then we have, sorry, the median, which is going to be 92. You have the upper quartile, which is going to be 98. And then you have the upper extreme, which is going to be 104. Okay? So now you've got your box plot all labeled, nice and careful. There you go. When you're doing this, you're just going to fill in this here and say that this is the ops with rational numbers test. And the average score for the class was the mean. And we had the mean score, which was what? Take a look. It was 88.8. So we're going to write that in as 88.8% average. Okay. And then when we go over here to our linear line graph here, all we got to do is right here, like we could do, let's say, R numbers for a rational numbers test. And then we're just going to put 88.8 in here. So 88.8 looks like it's about there. Now, as we progress over time, you're going to start seeing a line plot for this, where we can see if you're improving or declining over time. But for right now, that's all we need to fill out. And that's pretty much how you do everything. So hopefully it makes sense. I'm going to zoom out so you guys can see the filled out results. That's what your paper should look like. All right, cool.